Eric Malmquist's job used to be a lot easier before renewable energy. Malmquist runs the power grid for Bornholm, an island of 40,000 people off the coast of Denmark. The island's electricity consumption is fairly predictable.
We can see people get up in the morning about 5:30. They're making something, and then they go to eat, so they just stop. And that's every day, and that's the curves we are making.
But the island's electricity supply is becoming less predictable. Like most places, Bornholm used to get most of its power from coal and gas. But now, more than half comes from wind and solar, which fluctuate constantly.
You can see the wind, and then suddenly it goes up and down all the time. Yeah, so it's very, very unstable.
Wow. As Denmark adds more renewable energy, that mismatch between when electricity is being produced and when it's needed is a growing problem. But this sleepy fishing village is home to a cutting-edge energy experiment that could make the variability of wind and solar less of a problem. Bornholm has branded itself the Bright Green Test Island and welcomed a series of futuristic experiments focused on the electric grid. The most ambitious experiment is called Ecogrid EU. At the demonstration house, project leader Maya Benson shows off how it works.
So this is some of the equipment that we are using in the project.
The Ecogrid project shakes up the traditional relationship between electricity supply and demand. It gets people to use more power when there's lots available and less when there isn't. It's called demand response.
So we have the control center and then the lines for the wind turbines, for example.
Benson uses a Lego model to help explain how demand response helps integrate wind and solar into the island's grid. It's something she learned about as a kid when her father installed a wind turbine on their property.
When it was windy, we turned up all the radiator valves full open and could heat the house. But because it was windy, the wind turbine was spinning anyway, the energy was free and abundant.
The Ecogrid experiment also relies on using more power when there's cheap, renewable energy available, and less when there isn't. But unlike when Benson was a kid, no one has to run around opening and closing radiator valves.
A signal goes through to the gateway and then a signal to the relay saying turn off the heat pump because now the power price is high and we are within boundaries.
The equipment gets information about the real-time price of electricity. When it's high, the equipment turns down the heating and turns it back on again when prices drop, so long as the temperature stays within a specified range, say 70 to 75 degrees.
Demand response have nothing at all to do with energy savings. It has to do with using the energy when it's there.
Which helps with balancing the grid, if it works.
And this is the part from the Ecogrid. They installed this one when I was signed in for the project.
Katri Marlison lives on Bornholm and is a participant in the project.
This is the price now. When it's red, it's expensive.
But although Marlison can access real-time electricity prices through the project, the devices controlling her heating system stopped working months ago. The automation equipment still has some serious bugs.
The idea of the project is really good, but then there's some technical problems that does that I can't use it the way it was supposed to.
Marlison sometimes checks the price before doing laundry or running the dishwasher, but those consume almost no electricity compared to heating and cooling.
It's a shame that it can't work the way that it's supposed to do.
She's not the only one who thinks so. Back on the mainland, I met Jørgen Christensen, the chief technology officer for Dansk Energi, the Danish Energy Association. He agrees it's a shame demand response isn't ready for prime time.
So we are over-investing because we're not utilizing the energy that we produce in a smart way.
Over-investing in things like transmission lines and backup power plants, which wouldn't be necessary if demand response worked better. Christensen is confident the technical problems with demand response will get sorted out. But he's worried that it will take time to convince people of the benefits. Maybe too much time, given the country's renewable energy goals.
If I would ask my sister whether she would have a flexible or smart charging of an electric vehicle or her heat pump, she would say, well, I haven't heard about it today. So that's where we are there.
On the left side you have a picture of Bornholm, and the green dots are substations.
On the campus of the Danish Technical University, researchers are tackling both the technological and the consumer side of the problem. They've been analyzing the results of the Bornholm experiment and are excited about its promise. But Jakob Østergaard, who's in charge of the lab, says what they've done so far is just the beginning and compares it to the nascent cell phone industry.
Yeah, you could say that what we have developed is basically we have developed the smartphone and one app.
The app being demand response. Now, in the analogy, Østergaard wants to build other apps to transform electricity in the same way the smartphone changed the phone. He thinks in a few years, we won't even think about electricity the same way.
Instead of buying kilowatt hours, which are very difficult to understand how much is a kilowatt hour and what is it, we could buy comfort, for instance. We could buy 21 degrees Celsius in our house.
That's a comfortable 70 degrees Fahrenheit. Whatever those new ways of thinking about electricity end up being, more likely than not, you'll find them on Bornholm first. For the PBS NewsHour, I'm Stephanie Joyce in Bornholm, Denmark.